Module 17.3, Day 1, Using Proportional Relationships. Content Standard. Use congruence and similarity criteria for triangles to solve problems and to prove relationships in geometric figures. Language objective. Explain the difference between direct and indirect measurement to a partner. Exploring indirect measurement. In this Explorer, you will consider how to find heights, lengths, and distance that are too great to be measured directly, that is, with measuring tools like rulers. Indirect measurement involves using the properties of similar triangles to measure heights and distance. During the day, sunlight casts shadows as shown in the figure. The dashed segment represents the ray of sunlight. What kind of triangle is formed by the flagpole, its shadow, and the ray of sunlight? Well, when we talk about a flagpole, we always assume that it's perpendicular to the ground. So then think of this is the ground, and that's the flagpole. Right, and the angle will always be a right angle at 90 degree. So then this is the sunlight, and think of it as this is the shadow. Okay, so then let's use that example to find our indirect measurement. Right, find the indicated dimension, use the measurements shown in the figure and the properties of similar triangles. In order to find the height of a palm tree, you measure the tree shadow, and at the same time of day, you measure the shadow cast by a meter stick that you hold at a right angle to the ground. Find the height edge of the tree. Since the two triangles are similar, right, so let's call the tree our x, and we can use proportional, so we can have x over 1 is equal to 7.2 over 1.6. And then we can, well, since we're solving for x, we just need to bring the 1 over, so x equal to 1 times 7.2 over 1.6. And from there, use your calculator to work this out. So then this gives us 4.5. Okay, and remember that in terms of meters. So when you guys look for the length, always include the unit of measurement. So then the palm tree is 4.5 meters. Okay, and here is another example. Say that Sid is 72 inches tall. To measure a flagpole, Sid stand near the flag. Sid's friend Miranda measured the length of Sid's shadow and the flagpole. Find the height edge of the pole. So here we give everything is in terms of inches, so we can use proportion, so that the height over the 72, and so in 128 over 48, and using the cross product, so 72 1 times 128, and use our calculator to work this out. So, and then divided by 48. So this gives us our height is 192, and this is in terms of inches. Okay, so now for number 3, your term, Liam is 6 feet tall. To find the height of a tree, he measured his shadow and the tree shadow. The measurements of the two shadows are shown. Find the height of the tree. Right, so since the two triangles are similar, so we can use proportional. We can say that the height over 6 equal to 28 over 8. And so then the height equal to 6 times 28 divided by 8. And then from there, just use your calculator to work this out. So then it's 21, but remember the unit of measurement is feet, so then you need to include as 21 feet. Okay, so now it's your turn to try these out. Using proportional relationship, refer to the figure for problem 1 through 3. The figure shows triangles ABC and DEF formed by a person and a tree with their shadows. The figures are not drawn to scale. Jim shown by the segment AB is 5 feet 8 inches. Okay, notice that the unit measurement are not the same. Okay, so then we need to convert everything either all into inches or all into feet, right? So I'm going to convert everything into inches. So then we have 5 feet 8 inches. Well, 5 feet, remember that one foot is equal to 12 inches, right? So then we can do 5 times 12 plus 8. So this gives us 68 inches. So then we can label this is 68 inches. And he said that he cast a shadow of 6 feet 40 inches. So then we need to convert this into inches as well. So you do 6 times 12 plus 4. So the shadow is 76. Right? And shown by these, and the shadow of the tree is 19 feet. So then you also need to convert this to inches. So you do 19 times 12. So this is 228. So to find the height of the tree, which is from D to E, so call that X, so then we can use proportion. So we have 68 over X equal to 26 over 228. Okay, and from there use our cross product. So I'm going to erase this part. So I'm going to have 68 times 228 equal to 26 times X. So then 68 times 228 over 26 equal to our X. Okay, so then this gives us 596.31 inches. Is in terms of X. Okay, and if you want to convert back to feet, then you need to take this number divided by 12. Okay, so then the height would be 49.69 feet. Okay, so let's go on to number 2. So I'm going to erase this. Okay, so from 2 it said Alicia is 5 feet 4 inches tall. She casts a shadow that is 6 feet long. Okay, so similar as before, you need to convert all those into inches. So then this is 64 inches. The shadow 12 times 6 is 72 inches. The tree casts a shadow that is 18 feet long. So then you convert 18 feet into inches. So this is 216 and call that X. Right, so then now you can set this up. You can say X over 64 equal to 216 over 72. So then solve for x, so x equal to 64 times 216 over 72. And then from there, just use your calculator. So this gives us 192, and this is in terms of inches. And to convert back to feet, you can take 192 divided by 12. Right? So then this gives us 16 feet. Okay, so then we have the answer in inches and also in feet. Right. Okay, and for number 3, explain why triangle ABC and DEF are similar. Right. Well, then this is a right angle. This is a right angle. So then they both are right triangle, and this is parallel to the ground, and this is parallel to the ground, right? And they have the same sunlight, so that means that this angle and this angle are congruent, and then they're perpendicular to the ground. This angle and this angle are congruent. So then the two triangles are similar by angle, angle, and angle. Okay, so then that's the end of our notes for 17.3 day 1. So your book work is number 1 through 5, 10 through 13, and you have your new HRW, and you are to copy down 17.3 day 2 notes.